Okay, today we will learn about one-dimensional motion. Suppose I am initially at point A and I am going to point B in a straight line. Suppose when I start from A, I start with velocity u, and when I reach to the point B, then suppose my speed is v. So, and I am going in a constant acceleration a. So my initial velocity is u, final velocity is v, and here acceleration is a. So we know that acceleration means change in velocity divided by change in time. So that must be final velocity minus initial velocity. Change in velocity should be v minus u by, suppose I took t time to reach from point A to point B. So this will be v minus u by t. That means at will be equal to v minus u, implies that v equal to, if I took u from this side to this side, it will be u plus at. So v equal to u plus at. This is general approach. So now if we, this is general approach. Because we derive it from the definition of acceleration. This is the formula. So when you have some initial velocity and you know that you are moving through a constant acceleration, you know the time, you can't derive what will be your final velocity. Okay, so if u, a and t is known, then you can find the unknown v. Now we will try it from knowledge of calculus. So we will see calculus approach. We know from calculus a equal to dv dt. That means v equal to integration a dt, because we know integration means anti-differentiation. Now a is constant. It is given that we told that we are moving in a constant acceleration, so a will come out integration dt. And suppose we took t time, so the limit of time is, initial time is 0 and final time is t. So this is dv equal to a dt. So if you integrating both sides, integration dv equal to a dt, so it will be integration dv. And at 0, at t equal to 0, the v was u, and when final time t, the velocity is v. So let's say it is a, okay, so this will be integration dv means u to v, so it will be v minus u equal to a into t minus 0. So this will be v minus u equal to at. That means v equal to u plus at. So using calculus also we can find v equal to u plus at. Okay. Now we want to find how much distance we covered. Suppose from A to B the distance is S. So in 1D now we will find what is S. First start with general approach. Suppose if I draw V versus T, velocity versus time curve, then you can say, suppose at t equal to 0, what was initial velocity? It was u, and suppose the final velocity is, suppose it take it as capital V. I did it capital V. Why? Because you should not confuse it with this variable V. Okay, so suppose this is the final velocity and this is capital V, and the initial velocity was u and final velocity is v, and it moves through constant acceleration. So speed increases in a constant slope is constant, and this slope is a, this slope value is a, because it is given that we are moving in a constant acceleration. Now you can see the, so S will be, we know S is area under curve, so we know that this area under curve is our S. So but it's tough to find the area under this curve. Now we can approach like this. So we can take an average value. If we take an average value, v plus average velocity, suppose we denote it as v bar, it will be v plus u by 2. Now if you take this average value, then and you multiply it with t, then it will be the same as the area under curve, because here you are here this extra part will be nullified with this part, so this area will be same as this area. Now so you can consider it that it moves with the constant average velocity throughout the way. So S is, we know that v bar into t, that means S should be v plus u by 2 into t. So S is v by 2t plus half ut plus that, and we know v means u plus at, so here we will put v, u plus at in place of v, by 2 into t plus half ut, so it will be half ut plus half a t square plus half ut, that is equal to half ut plus half ut equal to ut plus half a t square. So in general approach we find the formula of S. So if I know u, a and t, then we can find how much distance we covered. So we got two formulas, v equal to u plus at and S equal to ut plus half at square. Can I find this value of S with calculus approach? Of course we can. We have v equal to u plus at. Now we know that v means ds dt. So ds means integration v dt, or s equal to s is integration v dt. So integration v dt, but this v is also changing with time, so it is not constant. You cannot you cannot take out of integration. You cannot take this v out of integration, so it will be s equal to integration v dt. So how v is changing with time, you can write it as u plus at. V is u plus at dt, and t is from 0 to capital T. So sorry, t equal to 0 to t. So it will be, u is constant, u is the initial velocity, so it will come out u integration dt t equal to 0 to t plus a integration t dt t equal to 0 to t, and this will be u into dt t minus 0 plus a into t square by 2 0 to t. It is definite integral. You will learn it in mathematics. U into t plus half a, and first we will put this t in front of this, so it will be t square minus 0 square, so it will be s equal to ut plus half a t square. So we need to remember these two formulas, v equal to u plus at and s equal to ut plus half at square in case of one dimensional motion or rectilinear, but it is also called rectilinear motion. This motion is confined in a line, in a straight line. Okay, now suppose we know u, a, t, we can find v, or if you know v or a or t, you can find u. So if you know any three of these, you can find the fourth one. Here also, if you know any three of these, u, t and a, then you can find s. You know u, s and t, you can find a. So from these two formulas, if you know any three, you can find the fourth one. Now suppose you know the value of v, value of u, value of a, you have to find the value of s, but you don't know the value of t. How can you do that? So here from these two formulas we need to know the value of t, but I have given these three values v, u and a, and I have to find s. How can I do that? So we'll see that in next. So we know v equal to u plus at, and we also know s equal to ut plus half a t square. So now suppose this is number one equation and this is number two. So from number one, if I can eliminate t from these two equations, I can find the relation between v, u, a and s. So now from equation 1 we can find the value of t, and that will be v minus u by a. We'll put this value of t into the second equation, so that will be s equal to u into v minus u by a. Just in place of t we'll put the value of t, plus half a into v minus u by a whole square, and it will be s equal to uv by a minus u square by a plus half a into v minus u whole square, so that will be v square plus u square minus 2uv by a square. So it will be is equal to, or you could took it as it is. Well, let's make it more simple. You can take v minus u by a as common. V minus u by a, you can take this as common. Now it will be just u plus half a into v minus u by a. So it will be s equal to v minus u by a into, it will be by 2, so 2u plus v minus u. So now it will be v minus u by a into v plus u by 2. So now if I multiply 2a with s, then it will be 2as equal to v minus u into v plus u, that will be v square minus u square. So you can write it as v square equal to u square plus 2as. So this is our third formula. From this you don't need t. If you know v, u, a or s, any three of them, you can find the fourth one. Thank you.